Okay, so we're going to move on to chapter 9, and I think that's where we will conclude for the remainder of the school year. Okay, so we'll finish up chapter 9, which I said was the most important chapter in second semester in Math 2. Okay, so here comes the famous Pythagorean theorem. Some of you probably already know. Um, you've probably seen it, and there's probably actually, I read somewhere, there's probably over 100 proofs on where the Pythagorean theorem comes from. And if you're really interested, there is a proof in your textbook. You can take a look. I believe it's on page 518 in your textbook, page 517 in your textbook. Okay, so if you're curious about the proof, there's a real simple proof. But out of the interest of time, I'm not going to go over that with you due to distance learning. Okay, so basically your Pythagorean theorem states that if you have a right triangle, right, again, a 90-degree angle, in a right triangle, right, the longest side, the side that's opposite the right angle, this is called the hypotenuse. Okay, this is always the longest side. And these two guys right here are called the legs. Okay, so a little bit of vocabulary. And the way I like to memorize the Pythagorean theorem, right, is to think about, what's the hypotenuse, what's the leg, right? Or what are the legs? So the Pythagorean theorem, quite simply stated, is the hypotenuse, actually I'm going to abbreviate, okay, HYP is the hypotenuse squared, is the sum of the two legs squared. And that really is your Pythagorean theorem. Okay, hypotenuse squared, the longest side squared, is the sum of these two legs squared. Now, oftentimes in textbooks, right, the way you have students memorize it, right, maybe call this side length C, and maybe call this side length right here B. If this is angle A, call this guy right here A, right? You can think of it as C squared, excuse me, is equal to A squared plus B squared. That's another way of memorizing it. But if you write C squared equals A squared plus B squared, it's not, it doesn't give you much specific information, right? It's like, what's C, what's A, what's B? But C, if you think about it this way, right, the hypotenuse squared is the sum of the two legs squared. I think this creates or fosters better understanding as opposed to memorizing C squared equals A squared plus B squared, okay? But this is what they mean. They mean the hypotenuse squared is the sum of the two legs squared. Okay, the hypotenuse is always the longest side. It's the side that's opposite the right angle. And again, there's over 100 proofs on where this formula comes from. Okay, all right. So you might hear some other vocabulary terms in your homework. Pythagorean triple. What is that? It's basically integers that satisfy C squared equals A squared plus B squared. Okay, integers that satisfy the Pythagorean theorem. And if you're like, what are integers again? Nice numbers. 1, 2, 3, 4, 5, dot, 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 dot. Okay, so you can't have any decimals in case you're wondering what an integer is. And these are some of the common Pythagorean triples. A 3, 4, 5 right triangle is very, very common. And so if x is equal to 1, right, this is the multiplier, you'll get 3, 4, 5. If x is equal to 2, if I multiply, I'm going to get 6, 8, and 10. Okay, this forms a Pythagorean triple. This forms a Pythagorean triple, right? These are all integers that satisfy this equation, right? 10 squared is equal to 6 squared plus 8 squared. 5 squared is equal to 3 squared plus 4 squared. And so forth. Okay, so 5, 12, 13, that's another common right triangle. If x is equal to 1, you get 5, 12, 13. If x is equal to 2, you're going to get 10, 24, 26, and so forth, right? If x is equal to 2 for 8, 15, 17 triangle, you get 16, 30, 34. And if x is equal to 2 over here, you would get 14, 48, and 50. Okay, so what's so useful about Pythagorean triples is that sometimes when you just recognize, hey, this is a 3, 4, 5 triangle, you don't need to use the Pythagorean theorem. You can just, quite simply say, oh, if this is 4, this is 5, this guy right here has to be 3. You're given 5, 12, you know the third side's going to be 13. Okay, so it's just a quick way to, compute that third side length if you don't have time to show all your work on the Pythagorean theorem. Okay, and it's helpful for standardized tests if you just have these things memorized. Okay, so let's take a look at our first example. It says find the value of x. Simplify answers that are radicals. Tell whether the side lengths form a Pythagorean triple. Okay, so I have a right triangle, right? Pythagorean theorem only applies for right triangles. And we learned that the hypotenuse squared is the sum of the two legs squared. Okay, so this is the hypotenuse. This guy is being squared by itself is equal to the sum of the two legs squared. Right, these guys are the legs. Okay, and this is the hypotenuse. So it's not 15 squared plus, it's not 25 squared plus 15 squared is equal to x squared. It's 25 squared is equal to 15 squared plus x squared. Okay, so you can use a calculator, figure out what 25 squared is. That's 625. 15 squared, I believe, is 225. And you are solving a square root equation, right? Move the 225 over. And you're going to get x squared is equal to 400. And to get x by itself, right, you don't divide by 2, you take the square root of both sides. Okay, so you don't want to write plus or minus, right? Typically, I have you guys write plus or minus for solving square root equations. But because this is a side length of a triangle, you only want to take the positive square root. So x is just equal to 20. Okay. All right, now, to answer the other question right here, x is equal to 20, tell whether the side lengths form a Pythagorean triple, right? These are all integers, right? 15, 20, and 25. You would say yes. They do form a Pythagorean triple, right? And I'm going to move on to the next page. Okay, so same type of directions for different types of problems right here, right? Again, this time the problem is given to you in terms of radicals, and the concept does not change just because you have radicals, right? Hypotenuse, this is the hypotenuse squared, is equal to the sum of the two legs squared. So this problem is really just practicing the radicals. 3 root 2 squared is equal to x squared plus square root of 3 squared. Okay, so if I square root 3 squared, right, root 3 squared is just root 3 times root 3, which is the square root of 9, it's just 3. Okay, so just a little review of your radicals, right? Root 3 squared is equal to root 3 times root 3, which is the square root of 9, which is 3, right? But that's too much work. I would just memorize it, okay? So if I'm squaring a radical, whatever's inside the radical is just going to be the answer, okay? So root 3 squared is just 3. Root 7 squared is just going to be 7. Now over here, you kind of have to be careful, right? You're squaring not just the root 2, but you're also squaring the 3, right? So when you square a radical with a coefficient, this is going to be 9 times 2. Again, here's the work on the side in case you're like, how did he get that? This just means 3 root 2 times 3 root 2. You're going to get 9 times root 4, 9 times 2, which is 18. Okay, so a little bit of practice on your algebra skills, which is quite important, right? Okay, so last but not least, get x squared by itself. And when you take the square root of 15, you can't simplify that any further. X is going to be equal to the square root of 15. Okay, so take a look, right, to answer that final question, right? Tell if it's a Pythagorean triple or not. These are all radicals, right? In order for it to be Pythagorean triple, these values have to be all integers, meaning nice numbers. They're not, so you would say no, it's not a Pythagorean triple. All right, now take a look at this one, right? This problem does not give you 2 side lengths, right? It only gives you 1, but that's okay. We could still use our Pythagorean theorem, right? These guys are still the legs. This is the hypotenuse. So the sum of the two legs squared is equal to the hypotenuse squared. Okay, so again, if you want to memorize it as c squared equals a squared plus b squared, be my guest, but I like to memorize it as hypotenuse squared is the sum of the two legs squared. Okay, so if you square these, right, x squared plus x squared, that's 2x squared. I just showed you how to compute this, right? You have to square the coefficient, which is 16. Root 3 squared is just 3. You're going to get 2x squared is equal to 48. And this goes back to semester 1, right? How do I solve a square root equation? I need to isolate the x squared. X squared is 24. And remember, when we take the square root of both sides, we must leave everything in simplest radical form. Okay, so don't leave it as square root of 24. You're going to get 4 times 6, which is 2 root 6. Okay, so this guy right here is 2 root 6. This guy right here is also 2 root 6. Later on in this chapter, you will learn that this is actually a special right triangle. It's actually called a 45, 45, 90. But for today, again, we're just practicing our Pythagorean theorem. Okay. All right, so moving on to example number 2. Before I move on, right, this is not a Pythagorean triple, right? These guys are not integers, so you would just say no. Okay, given the side lengths of a right triangle, find the third side and tell whether it is a leg or a hypotenuse. Okay, so I have no idea whether or not these are legs or hypotenuses. But what I'm going to do right now is just call that third side x. And there's only a couple possibilities, right? These are either both legs or one is a leg and one's a hypotenuse, right? And let's take a look. If they're both legs, scenario 1, right? If they're both legs, right? A squared plus b squared is equal to c squared. That means this third side length right here, right, has to be the hypotenuse if they're both legs. And so you would take the square root of a squared plus b squared, right? So what I'm trying to state here is that if these numbers that are here that are given to you are both legs, you basically have to add these two after you square them, right? So you have to add, okay? All right, now, possibility number 2, let's say one is a leg and one is a hypotenuse, right? One is a leg and one is a hypotenuse. Okay, well, this equation is still going to be true, except you're given a leg and a hypotenuse, right? And so maybe you want to solve for b, and the way you solve for b, right, is you do c squared minus a squared, and b is the square root of c squared minus a squared. So if you're given one leg and one hypotenuse, this has to be the hypotenuse, right? Because it's the longer side, if it was. I'm not saying it is. Really, what you need to do is subtract the two numbers. And that's really what we're going to do to figure out if it's a leg, if it's a hypotenuse. We're either going to add the two numbers and square them, or square them and then add the two numbers, or we are going to square them and then subtract them. Okay, so those are the only two possibilities, and that's really the logic behind it. Okay, so whatever we have to do, right, we have to square this number, square this number, and square this number, and we either add or subtract the two numbers. So let's take a look. If we square 72, and if we square 75, and we square x squared, 72 squared, I believe if you use a calculator, you're going to get 5184. 75 squared, you're going to get 5625. And x squared is just x squared. Okay, so I squared all three values, right? X is my third side length. Now here's where you decide whether or not to add or subtract, okay? Or you could do both and then figure out whatever gives you an integer. Remember, these are, I should say, these are all Pythagorean triples, okay? Given the side lengths of a right triangle, find the third side and tell whether it's a leg or a hypotenuse, given it's a Pythagorean triple. that means that whatever number I have to have for x, it has to be an integer, okay? All right, so if I subtract these two numbers, 5, 6, 2, 5. Remember, subtract the smaller one from the larger one. I'm going to get 441. And I'm going to set 441 equal to my x squared over here. And if you take a calculator, right, and you square root both sides, you're going to get x is equal to 21, which is a nice integer. Okay, so I got a Pythagorean triple, right? X is 21. 72 and 75 are the other side lengths. And if x is 21, right, 72, 75, and 21, clearly this side length right here has to be a leg, right? This is the hypotenuse. This guy right here is the other leg. And I believe the problem was asking, tell whether it's a leg or hypotenuse for the third side. So this third side right here, that we computed is a leg. Okay, so how did you know to subtract? I didn't, okay? I just basically, I randomly guessed, okay, to subtract, to see if this would give me a perfect square. You could also add these two numbers, and I guarantee you if you add these two numbers, you'll not get a perfect square, okay? So, you know, let's just do it here. If you were to add it, 5625 plus 5184. Using my calculator over here. You're going to get a really big number, right? 10089. And if you set it equal to x squared, you're going to get approximately, you know, 103, right? This is 103.9. This is not an integer. And so I know I have to subtract the two numbers, okay? You're either subtracting or adding after you square two numbers, okay? So if this example didn't quite make sense, let's move on to the next problem here. Again, we need to square these two values. And we don't know what that third side length is. We'll call it x. Okay, so 12 squared, I believe you're going to get 144. 35 squared, you're going to get 1225. Okay, and of course, x squared is just x squared. Okay, so this time, if we subtract, right, let's just subtract these two numbers, smaller number from the bigger number. You are going to get, I believe, 1081. And if I set my value that I subtracted from equal to x squared, you're going to get approximately 32.8 on your calculator. Okay, so this is not an integer, right? But I wanted to make it an integer. Why? Because this is given that's a Pythagorean triple. Okay. Okay, now let's say we add those two numbers. If we add them, we're going to get 1369. We take this value, set it equal to x squared. And if you take the square root of both sides, right, you're actually going to get an integer, right? If you take the square root of this and this, you're going to get x is equal to 37. Okay, so this is an integer, which means it's part of a Pythagorean triple. And so my side lengths, right, 12, 35, and 37, right? This is the side that we solve for. This guy right here has to be a hypotenuse. Okay, and so that's how you compute whether that third side is a leg or a hypotenuse. You either subtract those two numbers after you square it and see if you get an integer. If it is, then you know that it's, in this case, you know it's a leg. Or if you add the two numbers, right, and you end up with a perfect square, and you get a nice integer when you take the square root, then in this case, you know it's a hypotenuse. Okay, hypotenuse is always the longest side, right? How did you know this was a leg? Because this is the shortest side. This has to be a leg, right? This is a leg, this is a leg, this is a hypotenuse. This is a hypotenuse, this is a leg, this is a leg.